Today's video will be a review for your first quiz on conics. So we look at the first problem. The filament of a light bulb is a thin wire that glows when electricity passes through it. The filament of a car headlight is at the focus of a parabolic reflector, which sends light out in a straight beam. Given that a filament is 1.5 inches from the vertex, find an equation for the cross-section of the reflector. Now we've done one other problem like this before. So when we look at the diagram, it's telling us that the headlight is 7 inches tall, and it's saying that the filament, the light, is 1.5 inches from the vertex. And if you remember, I said the easiest way to do this is assume that the vertex is at 0, 0. We see that our parabola is opening to the side, so I would start with our parabola equation. X equals, because x equals the sideways parabolas, a times the quantity y minus k, because remember sideways everything's kind of flipped, plus h. So we know that our vertex, which is representing the h and k, are going to be zeros. So now we're left with x is equal to a times y squared plus nothing because h is 0. So the only thing that we have left to find is this a value. And the a value we can find by knowing the p value, the distance between the focus and the vertex. Because remember, our p value equation is 1 over 4a. And we know p, we know the distance. The distance is 1.5 is equal to 1 over 4a. We cross multiply. 1.5 times 4 gives us 6a. 1 times 1 is 1. We divide by 6. So we find that a is equal to 1/6. So all we have to do is plug that in there. So the equation of our cross section is x equals 1/6 y squared. So when you have these filament problems, you're using p, the distance between the vertex and the focus, to solve for a to find your cross-section equation. Alright, next we are going to write the equation of a circle given the center and a point. This was what we did on the very first day with circles. So if we have a center, the center is our hk. If we have a point, that is our xy. And we go ahead and we look at the general form of a circle, which is x minus h, quantity squared, plus y minus k, quantity squared, is equal to r squared. And remember, when you have an equation in the end, the only variables that you should see are your x and your y. So let's go ahead and fill everything that we know in. We are told that our x is 3 minus h, and h is 5, quantity squared. Our y, which is 7, minus k, minus a negative 2 means that we're adding 2. And we don't know r squared. So r is what we are solving for in this case. 3 minus 5 gives us a negative 2, quantity squared. 7 plus 2 is 9, quantity squared. That gives us 4 plus 81. So we know now that r squared is equal to 85. The radius of our circle is the square root of 85, but you want to be careful because the equation of a circle is set equal to r squared. So you don't have to even worry about square rooting both sides. So we go to write our equation. We know that we're going to have x's in the equation, so x minus h, so x minus 5, quantity squared, plus y minus k, so plus 2, quantity squared, is equal to our r squared, and we found that our r squared was equal to 85. So just think about the circle equation, and if I were to give you an equation, I wouldn't give you all the information. I give you everything except for the x and the y. Okay, so now on to graphing our conic sections. Looking at number 3, I see that we've got x equals 2 times the quantity, y plus 5 squared minus 1. When I look at a conic equation, I first try to think about what is it. Well, I see that only one variable is squared, and I see that it's a x equals a y squared, so I know that this is going to be a sideways parabola. And as soon as I recognize the fact that it's going to be a sideways, which you need to do from the very beginning, you need to remember that everything is going to be flipped. So everything that you know from a regular parabola is going to kind of be switched around, except for the shape and orientation. So the shape and orientation is determined by the a value. And in this case, we're going to have that a equals 2. This is going to be narrow because it's greater than 1. Now normally the orientation is up and down, but because it's sideways, because it's positive, it's going to go right. If it was negative, it would go left. Alright, the next piece is the vertex. Now again, the sideways parabola, you don't want to just jump into the equation and say -5, -1. Remember, this is a y, so this is the y coordinate. Just like when it's an up and down parabola, this is an x and this is a y. So whatever variables inside the parentheses, that's the coordinate. Since y is inside, that's the y coordinate. So the y coordinate of our vertex is a -5. The x has been flipped to the outside. So the vertex is at -1, -5. No matter if it's sideways, up, down, coordinates of points are always x comma y. So you've got to look in the equation and find out where's the x, where's the y. So we have our vertex at -1, -5. Because we have a sideways parabola, we know it's opening right, so it's going to be going this way somehow. The axis symmetry is going to cut it in half. That means that we want a horizontal line. Horizontal lines are y equals, therefore we steal the y coordinate. If it was an up and down, then it would be x equals the x coordinate. So we have that axis of symmetry, and I do want this to be drawn on your graphs. Our y-intercept, if we have the y-intercept, we know that the x-coordinate is equal to 0. So we look at the equation, we plug 0 in for x, and we solve. Now you can't go to the calculator on this one like you did on the last one because our equation is set equal to x. In your calculator, it's always set equal to y. So these you have to do by hand. We move the 1 over, and this is solving from the last chapter. Before we can square root, we divide by 2. So we've got 1/2 is equal to y plus 5, quantity squared. Now we square root each side. And we've got plus or minus the square root of 1/2 is equal to y plus 5. So we've got y is equal to a -5 plus or minus the square root of 1/2. I don't want exact answers for the y-intercept, so you don't have to worry about rationalizing this and getting it into simplest form. I just want to know what the decimal is going to be, so don't waste your time rationalizing and doing all that kind of stuff. Just plug this into your calculator, -5 plus the square root of 1/2 and -5 minus the square root of 1/2. We plugged in 0 for x, so it's going to be 0, comma, when you plug in, you get a -4.29, and you get 0, -5.71. So we go ahead and put those points on our graph, and these are the y-intercept, so it's where it's crossing the y-axis, at a -4.29, so about there, and a -0.71, about there. Now we move on to the x-intercept. And if I'm looking for the x-intercept, I know this is when y is going to be equal to 0. So I go back to my equation. X is equal to 2 times 0 plus 5, quantity squared, minus 1. 0 plus 5 is just 5 squared minus 1. Make sure that you're following the order of operations. 5 squared is 25. We have to do that first. 50 minus 1 gives us 49. So this point is at 49, comma 0. That's not on our graph. We obviously don't have x going all the way to 49. So all we have to create this graph is that vertex and those two y-intercepts. So we're going to use those 2 points to draw our graph. Moving on, we have P. When we go to P, remember that the equation for P is 1 over 4a. So we've got to go back to that a value, which is 2. 1 over 4 times 2 gives us our P as 1/8. The focus and directrix are found from this p-value. P is the distance from the vertex. To find the focus, we go 1/8 inside of the parabola, and since it's going right, inside is right, and the directrix is 1/8 outside. There's a big difference though. The focus is a point inside. The directrix is a line. So this is going to be a line that is perpendicular to the axis of symmetry, and that's a vertical line. So we know that the directrix is x equals. Now we started at the vertex and we went left, so we're changing the x coordinate, so a -1 minus 1/8, and you can leave it as improper or you don't have to, so that could be a -1 and 1/8, or I would also accept x equals a -9/8. Either one would be correct, but you have to have the x equals showing that it's a vertical line. The focus, however, is a point, and that's a point inside, so we are adding 1, or 1/8, and that gives us the focus point. Our y value didn't change, so we're still at a -5. Our x changed to a -7/8, comma, -5, and those are the coordinates of that focus point. There's a lot to go with those parabolas, so make sure that you're studying all those important pieces. We still have 3 conic sections left. When we look at number 4, we look at the equation, and I know right off the bat it's either an ellipse or a hyperbola because it's got that set up. The difference between an ellipse and a hyperbola is ellipse, both of your pieces are positive, and in this case that means that this will be an ellipse. And I look and I see that I have an inequality sign, so I want to make sure that I pay attention to that when I make my graph. Our center, -2, -4. It's inside parentheses, so it's the opposite. 2 is our r of x because it's with the x variable. 3 is the r of y. Now here's the tricky part, is we have c's for ellipses and for hyperbolas. You've got to remember for the ellipse, it's the major squared minus the minor squared. The major is just the larger of the two, the minor is the smaller. So this is 3 squared minus 2 squared, 9 minus 4, which is 5. That gives us c squared, so we take the square root of that, and we find that c is about 2.2. So let's go ahead and get our graph started. We have a center at -2, -4, an r of x of 2, so we go right 2, we go left 2. Our r of y is 3, so up 3, left 3. Our inequality sign is greater than or equal to, which means we are going to have a solid line. That's really bad. Connecting our points, and remember this is a curved shape, kind of like a football. Now I want to go to the foci. I don't want to graph my foci until after I've drawn my ellipse because I don't want to be any confusion on which points do I connect together. The foci are the distance from the center, and it's 2.2 from the center. The foci will always go on the major axis for ellipses, and the major axis is y, so I'm going up and down. So from the center I go up 1, 2, 2.2, down 1, 2, 2.2. Since I'm going up and down, I'm changing the y coordinate of the center. So I take that -4 and I add 2.2. So my new y is a -1.8. The x did not change, so that's still a -2. And then I subtract that 2.2 to go down. So my new y coordinate there is a -6.2. And then our last step is our shading, because we have an inequality. You don't shade unless there's an inequality. I always use my test point of 0, 0. I go to plug that in. 0 plus 2 gives me 2 over 2, which is just 1 squared, plus 4/3 squared. I want to find out, is that greater than or equal to 1? Well, yes, this right here is 1 squared. I'm adding another number to that, so yes, that is true. Therefore, 0, 0 is part of the solution set, which means if it's true, that is the direction that I'm going to shade. Since the point that I chose was true, that's the direction I shade. So I'm shading everywhere outside of the ellipse. Next, We have x plus 6 quantity squared plus y minus 1 quantity squared is equal to 16. We see that we don't have any r of x's or r of y's, or it could have been r of x of 1, r of y of 1, which is kind of there. But we know that this is going to be a circle because the x and the y have the same radius. So we know right now it's going to be a circle. The center, -6, +1. And our equation for a circle is set equal to r squared. So r squared is equal to 16, therefore r is equal to 4. Our radius is not always a nice number like that. So sometimes when you have ellipses or hyperbolas, your radius might be the square root of 10. So don't get freaked out if it's not always perfect. So we start with our center at -6, 1. And then we have a radius of 4, so we go right 4, we go up 4, we go left 4, and we go down 4. And then we connect our points of our circle. Alright, we are on our last conic section for review. And either by elimination, but better yet, looking at the equation, it looks like an ellipse, but we have a minus sign. If one of the pieces are negative, then you have a hyperbola. We find the center the same way. Opposite of a -2 is a +2. Opposite of a +1 is a -1. Your r of x is 3. Your r of y is 5. So we're going to start there. Don't go any further yet. We go to our center, 2, -1. We go our r of x, 3 right and 3 left. We go our r of y, which is up 5. 1, 2, 3, 4, 5. Down 1, 2, 3, 4, 5. We use these 4 points to create a box. This box is not actually part of the graph. We use it to create the shape. And yes, you have to draw the box, and I want it as a dotted line because it's not actually part of the hyperbola graph. Once you have your box, then I want you to draw your asymptotes. We're not going to get to the asymptote equations until the very end, but you need to draw the asymptotes in now so that we can see the shape of our hyperbola. Use a straight edge. Your ID works really, really well. I don't have a straight edge that works on these tablets, so I'm just going to do this freehand. It has to go through the corners and through the center. Some of your graphs have kind of gone up and down, and so make sure that you're connecting this corner to this corner and it's going through the center. And we do the same thing for the other side. It should go through this corner, and the center. And using a straight edge, make sure that you have an accurate line and you don't have a curved line. So now I'm ready to get started drawing my hyperbola. I look at my equation. I look for the positive axis. I see that x is the positive axis. Therefore, the points that I made using my r of x are going to be my vertice points. And my r of x was going right 3 and left 3. So this is my 2 vertices. 5, -1. And my second vertice is -1, -1. I am now going to draw my hyperbola. I use that vertice point, and the asymptote is where my line approaches but never touches. So it's going to approach that dotted line but never touch. It's going to approach but never touch, approach and never touch. That's giving your shape of the graph so you can see how wide the graph is. That's the whole point of the line. So if you draw your hyperbola like this, you're going to get it wrong. Go and approach those dotted lines. So now that I have my hyperbola drawn, we can go ahead and fill in the rest of our information. If we are finding C, for the ellipse we subtracted, for the hyperbola we add. So 3 squared plus 5 squared gives us 9 plus 25, which is 34, but we've got to take the square root of 34, which is going to be about 5.8. The foci are going to go in the same direction as the hyperbola because the foci are inside of the hyperbola, just like the foci are inside of the ellipse, and the focus is inside of the parabola. So if I'm going to go starting from the center, I'm going to go right 1, 2, 3, 4, 5.8. From the center, left 1, 2, 3, 4, 5.8. Sometimes the foci are really close to the vertices, sometimes they are really far apart. So you don't always know it's going to be one or the other. Since we moved left and right, we are changing the x-coordinate of the focus of the center. The x-coordinate was 2. So we've got 2 plus 5.8, giving us our first foci at 7.8. The y didn't change, so it's still -1. And then we moved left, so we subtracted 5.8, giving us a -3.8, comma -1. And last but not least are our asymptotes. And when we look at our asymptote, we're going to put this in point slope form, which means we need a point and we need our slope. The point we're going to use is that center at 2, -1. And you find your slope. I go up 1, 2, 3, 4, 5, right? 1, 2, 3. So that's 5/3. But I also go in the other direction, and so my other slope is a -5/3. So we've got y minus y1, so that's y plus 1, is equal to a +5/3, parentheses x minus 2. And then our second equation is exactly the same, except for we have a -5/3 now. And that is all for your review video for your quiz.